Welcome everyone. This is Zahid Bashir. Today we are going to discuss the uh, ninth day regarding our Stata training. And previously we were discussing about the step-by-step procedure of using Stata for data analysis. There are some things that are remaining in that file, and we will discuss this in the later part of today's discussion, like hypothesis testing procedure using pooled OLS and how you can use Stata and ESCAT commands in generating your publishable results and how you can create your out. There was a temporary interruption in the Wi-Fi connection, but I have managed to connect it through mobile internet. So let me start it again. I was discussing that today we will discuss how we finalize our model. And there was a command which is known as ladder and ladder. I will share the document, but uh, at first I will let you know how you can transform your data. If your data is non-linear or if it shows not normal trend in your analysis, how can you transform your data in order to make it normal from not normal or linear from not linear. So if your data is not normal, or if your particular variable, especially dependent variable, is not linear, there is a technique which is known as ladder and ladder technique that you need to understand. So you may have potential transformation, like you can take log, you can take square root, uh, you can raise your variable to some power. But how? But what is the actual transformation? How would we decide that which transformation is basically suitable to our variable? It basically decided from the ladder and ladder technique. So selecting the appropriate transformation is somewhat an art. So Stata includes the ladder and ladder commands to help you in this process. So ladder reports the numeric results and ladder produces the graphic display. So at first, always remember that you need to transform your dependent variable if it is showing the non-linearity or non-normality in the data. So let's have a quick understanding of this procedure. So let me start the software first. For example, I have shared some data with you. So let's suppose I am using that particular data again, like CG data that I have previously shared with you. So in case of normality checking of the residues, you remember that first we need to run a regression like Tobin's Q on these set of variables in this way, and you need to put drops. And after doing it, you need to predict your predict E, comma, resides, and it will create a command. We need to check the actual command from here in order to create the predicted E value. That was predict E reside. So whenever you are a doubt, because there is a spelling mistake here, so you need to write there reside. The, the extra was E, that's why the command was not run. So when E is generated here, you need to check the normality of your data. So after confirming that our data is not linear, we can go for transformation procedure. So let's suppose I would run S will E command. S will E. It is showing us that the p-value is less than 5% because the interpretation states that if the p-value is less than 5%, it means residuals are not normal. So once it is finalized, the data is not normal or not linear. In that case, you need to transform your dependent variable. So what I need to do, I need to write here LADDER, ladder. Now I need to put here my dependent variable that I have used in this model. That is Tobin's Q. So I need to select from here the Tobin's Q with ladder. So it becomes ladder with Tobin's Q. I need to enter and it will show me these kinds of results. Now, what I need to choose from here, this technique says that check the method of transformation with low chi-square value. So you will see here the chi-square and you need to choose the low chi-square value here. There is only one, you can say, value which is showing the chi-square value and all are significant. So we can apply any method from here and we cannot still just we cannot still decide which method is suitable. In that case, you can apply another command which is known as glider and it will show you the graphical display. So you need to apply the glider because here we can not be able to understand which technique is suitable. So you just need to apply here the ladder technique, ladder. It will show you graphically which method is more suitable in order to make your dependent variable transformed, suitably transformed. It will show you because this is basically running, this is running the procedure and it will generate some results. So you need to understand the bell-shaped curve. If you see the cubic, it is not showing a bell-shaped curve. If you see the square, it is also not showing a bell-shaped curve. Identity is also not showing the bell-shaped curve. But if you see square root, log, 1 divided by square root, 1 divided by square root is basically showing a bell-shaped curve and the others are not correctly showing the bell-shaped curve. So you need to concentrate which method is correctly showing the bell-shaped curve. So here 1 divided by square root. So you can also check here the 1 divided by square root method is showing the chi-square value and it is significant. So it means that we need to transform our dependent variable using this method. So what I need to do, I need to generate a new variable. So I need to write generate. I can write new Tobin's Q, new Tobin's Q, or I can also write Tobin's Q 2. Let it be the name of transport variable, transformed variable, Tobin's Q. The formula would be generate Tobin's Q is equal to. Now I need to write this formula as a transformed variable. So how can I write? I just need to copy it from here because it is basically the formula for transformation. So I just need to copy it from here and put it here like this. 1 divided by square root of Tobin's Q. So press enter and you will see Tobin's Q2 here. Now it is a transformed variable. So what we need to do, we can run a new regression like this. Just put it here. And you need to replace previous Tobin's Q from here with the new transformed Tobin's Q as a dependent variable. Now your new transformed variable is here while you are using the same independent variable. So press enter and you will see your results. You can see here the R square value as a 30% model is fit and majority of the variables were significant. And if you compare it with the previous results, your R square value was only 21%. And now what is it? It is 30% now. R square value has increased. And how many variables were insignificant previously? Previously, parrot was insignificant, F age was insignificant, S growth was insignificant. If you see now, uh, parrot is still insignificant, F age is still insignificant, but S growth is significant now. So this has changed the result. Secondly, you can also verify, you can also create a new predict E. First, you need to drop the previous E because previous E was related with the previous model. So you need to drop the previous E because now your dependent variable has changed. So you need to create a new E. So how can you do it? First, you need to drop the previous E. And for doing this, you just need to go here. You need to right click and drop selected variable. So it will drop the previous E. Now you need to create a new E or new residue. So how can we create it? Just copy this command and just put it the command here like this. It will generate a new E based on the recent model which we have run with Tobin's Q2. So what I need to do, I need to check the normality of our data using S will E. You can do it. It is again showing, I think it is showing the previous one. We can still see whether there is any problem. Let me run the command again here and let it let the S will E. If it is showing still the same results, we need to still check whether it needs more transformation. So we can run again the ladder with Tobin's Q2 and we need to see it is providing more of the formulas. Now it shows that if you are using the same formula, it will also be beneficial because it is showing the less chi-square value with the identity. Identity means the same formula. You don't need to transform this. So it is providing that now your variable is transformed. So if it's still not normal, it means you need to increase your you may say that your sample size. You need to increase the sample size in this case because if the identity variable is giving a lesser chi-square value, it means the same formula is used for transformation. So the formula is correct. So what does it mean? It means that your data has become linear, but your data is showing non-normality still. So it will be resolved with the inclusion of by increasing the sample size. So this is how you can transform your variable. We have applied. So let's suppose I will try another dependent variable like ROA. So let's suppose this is our regression command and we are using ROA uh, uh, instead of Tobin's Q and we run a command like this. Now, what you need to do, you need to uh, drop the previous E from here. Again, run this command and you need to predict E on the basis of this command. So again, run this command like this, and you need to predict E on this command. So you need to copy your predict E command from here like this. Now new E is created. Now you need to check the normality. S will E in order to see whether it is normal or not. It is also showing that it is not normal. So we can check the ladder on ROA. So let us check what it shows. It is it shows nothing in the chi-square table, but it shows the p-values, the three different p-values. Like uh, it shows that identity value is also significant. It shows that inverse of your original variable is also significant. Inverse of a cubic variable is significant. So we need to identify the ladder ROA, and we will see the graphical representation whether it shows some whether it requires some transformation or not. Maybe it would not require any transformation. If you see these graphs, the only graph which is showing some kind of uh, you can say the bell-shaped curve is identity. So identity means that you don't need to transform your variable. It means that you are going to use the same variable. You don't need the transformation. So here in this case, our variable ROA is basically better. It doesn't not, it does not require any transformation. So in this way, you can check the transformation of any variable whether it requires some transformation or not. So always depends upon the lowest chi-square value as well as from the bell-shaped graph. If both confirm the same thing, that then you need to apply that particular formula using generate commands that I have previously used like this. This is the command. Generate new variable name, and then you need to copy from here which formula is uh, you are going to apply. Like I have applied this formula, so it gives me uh, the value which makes the R square better, which makes a lot of variables significant in my case. So many of the people often contact me that their variables are not linear or their variables show non-normality in the data. So how they can make corrections in their data set. So I always suggest them that try the ladder and ladder technique in order to make transformation in their dependent variable in order to make your results more reliable. So what we need to do further in today's discussion, the remaining part that I have previously could not cover is how we would decide. Again, there was a network interruption. So I was discussing which variable you should retain in your model and which variable you should drop in your model. So this was the part which was remaining previously, and today I will also discuss that how you can generate ready to publish tables. How can you generate the APA style tables using Stata? There are some certain commands that you can use uh, for generating the tables for this purpose. So the first thing that you need to understand as a general guideline for building a regression model is that make sure all relevant predictor like independent variables are included. So how you decide that these are the relevant variables, relevant independent variables that should be included in your model. You have decided your DV. But how did you decide about your IVs or your control variables? So the procedure is that you need to base your research questions, theories, and knowledge supported by your literature. So always check the literature that which IVs are basically relevant to your DV. Do not include irrelevant IVs in your model. If the IVs, if the IVs are supported by the literature, if the IVs are supported by your research question, your theory, or the knowledge on the topic, then you should consider those IVs into your model. The second thing that you need to understand is combine those predictors that tend to measure the same thing. So sometimes you need to consider an index measure. For example, let me tell you here. All right, let me show you here. For example, I want to measure firm performance. That's it. Now I know that it is measured by ROA, it's measured by ROE, it's measured by Tobin's Q. So instead of using ROA, ROE, and Tobin's Q, why should not I use the combined measure which shows the firm performance on the basis of these three? Maybe I aggregate these three or take an average to consider the firm performance. So in this way, combine those predictor or combine those variable that measures the same thing as an index. Like you may have heard about ESG, that is environment, social, and governance. ESG, environment, social, and governance. And most of the researchers are using the index. They take the value of E, S, and G, and they combine those values to consider a common measure. So always try to use an index measure for those variables that are going to measure the same thing. So consider the possibility of adding some interaction. Interaction means sometimes you need to have a moderating or mediating variables in your model. So sometimes your results are not according to the theory in a particular sample or in a particular population. Your results are not according to the theory. In that case, you need to consider the moderating or mediating variables along with your existing model. So always remember that this choice of mediating and moderating variable depends upon your research question and research objective. Now, what is the strategy? Whether we should drop a particular variable or we should keep a particular variable. I have established some criteria in order to finalize a particular model. So you need to understand this particular criteria. For example, if your independent variable is not significant and has expected sign. Expected sign means that it is provide the sign according to some theory, the theory that you are going to test. If theory says that the sign should be positive and it is giving a positive sign, but it is not significant, then you should keep it. Always remember that you are going to test a theory, you are going to test some hypothesis. So if the variable is giving the expected sign, but it is not significant, you need to keep this variable. The second thing, sometimes your variable is not significant and it is not giving the expected sign. Like the theory says that that particular variable should provide a positive impact and you observe a negative impact and it is also not significant. In that case, you need to drop that variable because that is not useful for your analysis because it is giving the sign which is totally different from your hypothesis or from your theory. and it is also not significant. So it becomes irrelevant for you. Sometimes your independent variable is giving the significant sign, and it has the expected sign. It means it is significant as well as it is giving the sign which is as per the theory or as per the hypothesis. Then you need to keep it. So what we have finalized, if you have an expected sign for your estimation, whether it is significant or it is whether it is significant or it is not significant. If it has expected sign, you always keep it. But if you do not have expected sign, uh, whether it is significant or not, you need to drop it. Will it be decided after collecting data about variable? Yes, this will be decided about collecting data, available data. Basically, there are different techniques of different researchers. Some of the researchers basically collect data, analyze results, and then they start writing their literature review. So if you are if you analyze your data first, and after finding some fruitful results on your as per your expectations, and then you want to write your literature, then you should apply this technique. So what we have decided yet, if your estimations giving you expected sign, whether it is not significant or whether it is significant, you should keep that variable. But if it is not giving you expected sign, then you should drop it. The next thing is, sometimes the predictor is significant, but it does not have expected sign. What to do? In that case, if it is significant but it is not giving the expected sign, you need to review your data. You need to review your particular variable. Maybe it requires some interaction, like maybe you need to add some mediating or moderating variable, because moderating variables sometimes change your expected sign. So maybe it required some moderation in order to have your expected sign again. So let's suppose I am expecting that leverage should have leverage should have a positive impact on firm performance. Let's suppose this is my expectation, but I notice that in my regression results, it gives me negative sign. I find out this. No, but this is also significant. Now, according to my criteria, or according to my basic criteria, if I have a sign which is opposite to my expectation or my hypothesis, but it is also significant, then in that case, I need to add an interaction term like moderation. Now, what is moderation actually? Moderation do two things. Moderation basically changes the direction and impact of an IV on DV. So, as in a simple regression, my sign is opposite. So, maybe by adding some moderation, the signs become positive. So, let's suppose I consider a moderating variable. Let's suppose I would consider a moderating variable of industry type as a moderating variable along with leverage. So I would multiply the industry type along with leverage. and see its impact on pump performance. And this time it shows me positive plus significant. Now it becomes according to the expectation and theory by considering a moderating variable here. So what we have learned from this fourth option is that whenever we have an independent variable significant, but it is not giving the expected sign, you don't need to drop it. You need to review it. You need to have more variables or some interaction term is required so that you can change the direction. So the next thing is you also need to check the formula that you have applied for measuring that particular variable. Maybe your formula is wrong for collecting the data on that particular variable. You need to check whether you have measured leverage from a correct formula. You may need to change the formula with another measure. For example, some measures leverage with debt to equity ratio. Some measures leverage with debt to total asset. So you need to check whether in case of this formula, it is not giving expected sign, then you need to try the other formula. So this is very important that what formula you have applied and it is giving a wrong estimation for your results. There is less than 1 minute remaining. If the meeting ends, please join with the same link so that we can start over from here because there. All right. We have considered again. I was discussing the scenario where we need to consider whether we need to keep a variable or we need to drop a variable. So increase number of IVs if limited. This is another consideration. Sometimes your R square